Well, please be a little more specific in your questions.
I'm not a psychic mind reader.
That's right. I'm just a mind reader. I'm not a psychic mind reader.
No.
All right. This is sort of a general thing too. If I have what's the operation for that? Multiplication. I like it. And of course, before I multiply anything, what can I do? Reduce. Yeah, I can reduce first. Before I make the numbers bigger, I might as well take care of them while they're smaller.
Yeah.
So 3 goes into 9. 4 goes into 16. So you get negative 1 over 12. Okay. Let me stop there for a second. Is everybody decent with that? Okay. Yes? Of course. Yeah, we had this discussion. You work at a company and you say, boss, it looks like we'll make $6,000 next week. And actually you should have said negative 6,000. That's a difference. That's a bit of a difference. So what if I said this? What operation is this? It's subtraction, and then what can you make it become? Yeah, because minus and negative becomes positive. Can I do the same thing I did here? Oh, wasn't meant to be a trick question. I really want you to realize, why does this work? Why am I allowed to do this? I can only cancel stuff when I have opposite operations. So the bar means division. And the fact that these are sitting next to each other means it's multiplication. So multiplication and division do cancel, all legal. Does division and addition cancel? No. Are they opposite operations? Division and addition, are they opposite operations? Hell no. Right? So then you can't cancel. Does that make sense? The only time you can cancel things is if they are opposites of each other. So why am I allowed to cancel a 4 out of both of these? Because that's on top, it's multiplying, that's on the bottom, it's dividing. Division and multiplication are opposite operations. That's why they cancel. This is addition. Addition can't cancel division. Right? It wishes it could, but it can't. Does that make sense? So, well, yes. So let's see. So where did we have trouble? So I can divide both of those by what? Or yeah, and just to show you, what if I multiplied these real quick, just to make sure you guys understand why diagonal cancellation is fine. I'm not really canceling diagonal. I'm canceling straight up and down. Believe it or not. Because what is 4 times negative 3? That's right, it's negative 3 times 4. What is 9 times 16? That's right, it's 9 times 16. So aren't the 3 and the 9 on top of each other? So as long as one is on the top, one is on the bottom, and they're multiplying together like that, then they can cancel. I can cancel stuff out because they're opposite operations. So why am I allowed to do this? Because it really is 4 over 16. It really is. And why am I allowed to do this? Because it really is 3 over 9. And then I get negative 1 over 12. That's why that cross cancellation works, because all you need is one on top, one at the bottom, having the same stuff inside. You can kill that stuff. Yes, ma'am?
Could you do it without the cross casting? If you just did 4 times 3?
Yeah, you totally can, but then you get these larger numbers that are harder to reduce. Right? Yeah, okay. This one it wouldn't be too bad, but still, in general, it's better to cancel first. If you really don't want to, you really don't have to. As long as you reduce somewhere, I'm just trying to show you how it's going to be easier.
Because all of them are not canceled if you get like a number that will not go into.
If you can't, if it's impossible to cancel here, it will be impossible to cancel the answer. I really want this to make sense. What's the only way you can cancel stuff at all? Is if it has, what's the only way you can cancel stuff? If the top has the same something in it as the bottom does, right? So before I multiply, so if I had 5 over 9 times 7 over 12, does anything cancel anywhere?
No.
Why can't I kill a 3 here? Because they're both dividing. Division does not cancel division, right? You need one on top, one on the bottom. Saw one person in the homework canceling across. No. You multiply across. So I am guaranteed that I do not have to worry about trying to reduce after I multiply, because what's one way I can reduce? Break things up. Aren't things broken up already? So if nothing will cancel now, there's no way in hell something's going to cancel after I multiply them. I already see the factors. All right, so this will just be 35 over, what is that, 108? And then I'm not going to waste any time trying to reduce that, because I already know it won't reduce. That's another reason why I like to reduce first, so that I know for sure whatever I'm done with it. I'm done. Next one. Not sitting there going, let's see, 35, 108. Oh, shit. I know there's nothing because I already looked. Nothing there, nothing there, nothing there, nothing there. Screw it. I'm done after I multiply. Next. Does that make sense? All right, cool. So this parentheses means multiply because there's no other operation in here. It must mean multiplication. These parentheses are here just so you can see there are 2 negatives. That's really the only reason they're there. That's why I took them away when I replaced it with 1 sign. I took those other parentheses away. And then what would you do here? LCD. I love it. Do 9 and 16 have anything in common?
Yes.
Does 3 go into 16?
Yes. No.
How many times?
No. 4.
No. 4 doesn't go into 9. So they don't have anything in common. That's the one time that the LCD is 9 times 16 is this. So this needs a 16, and this needs a 9. Because they're both missing each other. Aww. Okay. Yeah, 64 plus 27 over 144. So what's up? Sorry? Exactly. You got to, before you can add them, you got to make the bottoms the same. So I give this guy him, and I give this guy him. So they both become 16 times 9, 144. All right, maybe.
Can we divide it?
Say again?
So the final answer, can we divide it?
Well, let's see. Does anything go into 91?
I know, but if there's like the positive number, can we divide it in the end?
You always have to check at the end to see if it will reduce.
Okay.
All right. So if you give me an answer of 4 over 12, you're going to lose points. Don't roll your eyes. That's too damn bad. That's part of what I'm testing you on, is can you recognize when something's not quite done. 4 over 12 is not quite done. I like it. So if you don't finish a problem, it shouldn't be a surprise that you will lose points. All right. Anything else from any homework stuff at all? Any other homework stuff? Did I get? Was that the one you were talking about? That kind of problem? Parentheses versus parentheses. Yes. Okay. Parentheses. Okay. Yeah, so here you multiply when they're sitting next to each other. But be careful if there's another operation in the middle, you don't multiply. You do that operation. It's not going to be multiplication. Yeah. Okay. Let me see. Yes. So if I had oh, what you got, Jeff? Oh yeah, but see, I could do 5 times 77, and then I could do 11 times 25, and get these really big numbers.
11 divided by
But I could right now, since 11's on the bottom and 77's on the top, I can divide both by, so that'll be a 1 and that'll be a 7. 5 and 25. 7. We're just going to start shouting random numbers. So then I get 1 times 7, 1 times 5, that's nice. Then I get negative, because 1 times 7 is 7, 1 times 5 is 5. What would that be as a mixed number?
2 and 5.
Yeah, 1 and 2 fifths. So depending on which way they ask for it, if they don't ask for it, you can give it either way. Even if they is me. Yes.
Number 399. Chapter 4.
Oh yeah, that's a yummy one. All right.
All your yummy ones are not yummy.
I know. You keep using that word, Jeff. I don't think it means what you think it means. If I gave you this, we've seen this problem before. If I gave you this problem here, and I know it's not the one you asked for, don't worry. I'm getting there.
Okay.
If you saw this problem here, what would you do? Can I kill those 2's?
No.
Why not? It's not.
Not multiplying.
It's not multiplying. I love it. So division can't cancel parts of a subtraction or addition problem. Whenever you want to kill something, take a second and say, do I have opposite operations? If you just do that, it'll save you from making really silly mistakes. So what do I do? How do I officially do this?
2 plus 7.
Yeah, 2 plus 7.
9.
9 is crazy. 5 minus 2.
3.
3. I like it. So, you've been sitting there so patient, you're like, that's not what I asked. Which one was it? 399?
Yes.
So if I add this problem, I can't go slower than that.
No, not yet.
Alright.
Speed on you.
I didn't know I was taking requests. Alright. Now, we're the humans here. We care that there are fractions in this thing. Math doesn't give a shit. Math says, you do this. It's something divided by something. So you got to do the top first something, and then the bottom something next, right? So how do I do this top? What do I need before I can do it? LCD. I love it. But sometimes when it's in a bigger problem, we forget we need LCD. I don't care where the fractions are sitting. You can't add them until they have an LCD. So this one you multiply by. So on the top here, you get 3 plus 2. Right? 3/4 plus 2/4. Right? Is? Okay, let me write it. 3/4 plus 2/4. We'll do that in a minute. Some monkey or something out there?
No.
And then this one needs what? What do I? Yeah, he needs 2. I like it, so they can both be 6. So now it becomes 5, 6 minus 4, 6. So what do I get on the top there? Good, 5/4. Divided by 1/6. Yes, ma'am. Okay. Now that looks still gross, right? But did you hear what I just said? It's 5/4 divided by 1/6. So maybe if you write it like this, it's easier to see.
Sideways, yeah. You understand more.
Yeah.
Understand better.
Yes?
Can't read it like
Nah.
that?
No.
What?
No.
You haven't got the answer yet, so
You still gotta do some stuff to it to make
you have
it
to. Is there still an operation there?
Yes, there is.
That is
Okay.
affirmative.
So simplify means carry out all the operations, right? So your an answer is not going to be 8 divided by 2. You got to tell me that's 4, right? So this is saying something divided by something else. That's not an answer yet. How do I divide fractions? I
Multiply the score.
5 fourths times 6. Dan has had some coffee.
It was not coffee.
Is everybody okay with this? I mean, the original problem looks disgusting, but what I did to make it easier is, what if I gave you that problem? I feel completely comfortable saying all of you should go, oh, good, this is easy. This is not, that problem right there is not a big deal. That's a separate problem that is equally not a big deal. So you just do the top, bottom on the top, and you do the bottom problem on the bottom, and you don't worry about the big-ass division until you're done with those. So part of mathematics is realizing you don't have to look at the whole damn thing at once. You look at the top, you look at the bottom, and then you worry about what to do. And something divided by something is that thing times the reciprocal, and what can I do here?
But by 2 multiply.
5 times 3 is 15
Over 2.
over 2. I like it. And if you want to, what would that be as a mixed number? 2 is then 15. 7 times? With
Half. Oh, 1 over 2.
1 left over. All right. Yes, ma'am.
What I was trying to say is like, you can't have decimals, hasn't it?
Oh, no. Hell no. Yeah. Especially not in chapter 4, because chapter 5 is officially decimals. Yeah.
Okay.
I know we all want to just take the number a calculator says, but that doesn't tell me that you know how to use fractions. It just tells me how you know how to push buttons. Yes. This one?
Yes.
Because it was already 4, and 2 can become 4. The only time I got to multiply both of them by something is if one of them can't just become the other one. So can 3 become 6? Yes, if I double it. So I'm going to leave him alone. And he's going to catch up to the other guy.
So you're saying 4 divided by 4 is
Sure. So I multiply by 1. I see people do that, but why? But if it makes you feel better, yes, do that. You gave it the one that it's missing. Yeah. Okay. Okay. How you guys doing? Anything else? Yes.
So when you multiply the top by, you multiply by the bottom, just to make the denominator the same?
Well, all right. Now watch. If I have a 1/2 sitting there, if I multiply that by 1, would anybody go, what the hell? I can multiply that by 1. I can multiply anything sitting there by 1 that I want to. Yeah. Because multiplication by 1 does not change it. I can't just suddenly multiply by 2 if I wanted to, because that would change the number. So I can multiply by anything that is 1. So I can multiply by 7 over 7. I can multiply it by 5 to the 0 power. Ooh, shit, because that's 1. Let's not do that. I want to do that weirdness. So I can multiply it by 2 over 2, because 2 over 2 is 1.
Okay.
So I'm making it look different. I'm making it look different, but it's the same number. So 1/2, one way to look at 1/2 is 2 is 1/2 of 1. We say it the other way around. 1 is 1/2 of 2. 2 is 1/2 of 4. So anything you make a ratio like that is fundamentally the same number. So that's why this is also 3 over 6 if I multiply by 3 over 3. Because 3 is half of 6. It's kind of freaky to think about it that way, but... So it says, for every 1 on the top, there's 2 more on the bottom. Alright, maybe. Alright, maybe. Yeah.
I have a question. If we have subtraction and the addition, sorry. which one comes first? Just like in 408. Subtraction and addition.
Oh, all right. We should all know this. Same answer with multiplication division.
Uh-huh.
Which comes first, multiplication or division?
Him does.
Whatever comes first. I mean,
Oh.
remember that? Neither one of them come first. It's just I do them as they come. So if subtraction is first and all that's in there, subtraction and addition, you subtract first. Exactly, as you read. I like it. That is what it means when I did this weirdness. These are on the same level. So who comes first? It's just whoever was there first. That's who comes first. Not always multiplication, not always division, just whoever's first. Same thing with addition and subtraction. Yeah.
Does the annual always have to be like the next number?
No. I just did that in case they ask. So it's either this or this. If they ask for one way or another. If they ask for improper, you better stop here. If they ask for mixed, you better go there. If they don't say, you can go either way. I like it. They're both the same value. It's just that as humans, I'd rather hear somebody say, I got 7.5 gallons in my car instead of I have 15.5 gallons in my car. So normally when you're answering a word problem, you would give it as a mixed number because we can think about that easier as humans. Yes?
So, but when you say simplified, make sure we do the mixed number, right?
Oh no, both of these are simplified. This is not more simplified than this, it's just in a different form. Yeah. So either one of those is valid unless they say leave your answer as a mixed number, and if you stop there, then you haven't done what it asked. Yeah. Alright. How you guys doing? You alright? Alright, good. Alright. Growth is pain. Growing pains. Alright. Okay, alright. So hopefully most of you, I thought I made more copies than I needed to, but I ran out of chapter 5 copies. I think one person needed it, so you can come see me in my office if you want a copy. So we're going to get into chapter 5. I'm not going to move the test. The test is going to be the same day, so this Thursday we'll know better exactly what it's going to cover. I don't think it's going to cover all of chapter 5, so we'll see. Depends on how far we make it. And don't forget, Thursday, quiz. Chapter 4, okay? What? Alright, let me start with seeing what you guys know about decimals. Alright. Good. They're specific fractions. They are fractions that work with our number system. And for some reason, our number system is based on the number 10. So if we had 8 fingers, our number system would be based on the number 8. We would have no number 9. That's freaky shit, ain't it?
Yeah.
Let's not think about that, but it's neat. So in my 120 class, I teach what would our number system look like if it was base 12 instead of base 10 and stuff like that. And you're like, okay, I know what I'm not going to take, but come on, it's neat. Don't worry, we're not going to suddenly do different bases. So let me just start with this. So let me just say 1, 2, 3, 4, 5. I have 123.45. What place is this in? Hundreds place. What place is this in? Tens. No, let me stop there. That's ones. Notice how every time I take a step back, I divide by 10. 100 divided by 10 is 10. 10 divided by 10 is 1. And really, just go with me for a second. The whole reason is, can you imagine like an odometer turning, right? You've all seen this idea of the odometer turning and it goes 89 and then it clicks over to 90.
Yeah.
Right? And then you go 9, 1, 2, 3, and then you get to 99, and now it's going to click over to 100 because I want to say I have 10 tens. But 10 tens is 100. You guys see what I'm saying? That's why the minute this gets up to be 10 of these, I just make the next place. That's why they go by tens. And of course they go by tens because we based it on 10, but times 10 is 100, so 10 hundreds would be 1,000. I just make one more place. So I don't have to put a whole, like, I can't put a 10 in this one spot, can I? So I got to space them out. So I'm going to say, oh, the next spot over then means 100. I'm going to have a teaching combat match. So this one then, if I just keep dividing by 10, divide by 10, what's 1 divided by 10? 1/10. I'm just following the pattern. This is all it is. So anything past the decimal is less than a whole number. Anything in front of the decimal is more than a whole number. And that truly is 4/10, for example.
45 cents, or if you do it in the
45 cents, exactly. Which is 45 in cents, of course. 1 cent is what part of a dollar? How many cents do you think? 100. It's 1/100th of a dollar. That's why that makes sense that this is going to be the 1/100th spot, right? 0.01 is 1/100th of a dollar. It's 1 cent. Is that cool? So that's the 100th spot, and so on. So the next spot would be the thousandths. This is where you bring in the lisp, right? With 10th, 100th, thousandths, yeah, exactly. And forever, ever, ever, ever after that, right? Literally forever after that. Let me stop there for a second. I just want to make sure we're on the same track. So, like I just said, if I saw 0.4, how would I write that as a fraction? What place is it in? Tenths place, so it's 4.
0.10, right? Or
It's 1/10. It's the 10th spot. So it's 4/10. Let me go back a step. So if I saw 4 sitting here, what does that 4 mean? It's 4 whats? 4 tens. Right? 4 times 10. That's 40, right? So this really literally means 4 of these. What's 4 times 1/10? 4/10. So don't even do this step. That would be 4/10. This would be 5/100ths. So if I saw 0.05, how do I write that as a fraction? Tenths, hundredths, 5/100ths. Let me stop there.
what is the point though?
Say again.
If you write that as 500ths, right? But you got 0.05.
Yes.
Where does that point at on the answer side?
It is not necessary. They're two different formats for the same number. So 0.05, is that less than 1 or more than 1?
Less.
5/100, is that less than 1 or more than 1?
Less.
Less. They mean the same number.
Right.
I don't need the decimal here because this is fraction form. That's why we call this decimal form, because the decimal has to be there for it to make sense.
Right.
If that decimal wasn't there, I wouldn't be sure which spot it was in.
Right.
Do I need it over here? No. Which spot is it in? I can see it.
Right, because because the decimal's on that side.
Yeah, so on this side of it, it must be smaller than 1. It must be some fractional part. I like it. It might be. So what about... I'll show you a couple tricks. All right. The simple way, the direct way is tenths, hundredths, thousands, 10,000s. Also, notice this. How many decimal places are there here?
3.
4.
1.
1, 2, 3, 4. You guys see that?
Yeah.
Not how many zeros are there. How many decimal places are there? 4. Now watch. How many zeros do I need then? 4. That needed 1 0. That needed 2 zeros because it matches how far out it is. Far out. Yes, ma'am.
So you count it that way. You count it right.
It really doesn't matter, but if you're saying names, you definitely want to start here. Tenths, hundreds, thousands.
You don't start with ones. You don't start with
No. Where's the ones? Yeah, ones is here.
Right.
So you could start there. You could start with ones as long as when you get here you say tenths. Yes. Cool.
Right, because you couldn't write the 1 on that side. So that's why you're saying you go from this on.
All right, here we go.
That make any sense?
Let me make sure I know what you mean. So this is
1.
1.
Right.
1, 1. This is 1/10. I like it. Because how many of these would it take to make a full 1? 10 of them. Sure enough, 10 times 1/10 is a full 1. So that's another way to look at why this is 1/10, because it's 1/10 of what you need to make a full 1. I like it. So decimals, I think the first thing somebody said was, decimals are fractions. They are specific fractions. They are based on 10, because they jive with our number system. So what about this one?
$35, 10,000.
Tenths, hundredths, thousandths, 10,000ths, 100,000ths.
Okay, you just going back.
And let me show you one thing that I don't know if, yes, in terms of some tenths, yeah. Now you could then reduce it. I'm just, right now I'm not even talking about reducing it at the moment, right? Because we already went through the fraction chapter, but you can reduce it. I'm mostly concerned right now with just going from decimal to fraction, and then if I can reduce it, I could. I might sometimes